Sorry, I'm going to stop saying okay. I know I start every video with okay. Okay? So, let's begin. I want to show, I gave that formula in a previous video. We saw it in class. I want to go over why that's true. And there's two keys right here. The first key is e to the log a is a. In other words, e and the log are inverses. In other words, these cancel if you want to think of it about that way, which we talked about in the last video. And the second is the integral from class on Thursday, 8/28, that says integral of ku du is e to the ku plus ck. In other words, if k is a constant, when we integrate, we divide. So let's go through that. So, I don't know, just real quickly what this means. Sorry. Something like this. E to the 3x dx would be e to the 3x over 3 plus our constant. Okay. So, I'm going to start with this integral, but I want to just look at that, a to the u, and this is going to be my capital A here. So this is equal to e to the log a to the u, and this is equal to e u natural log of a. And remember, the reason for that is that we have the natural log of a to the r is equal to r natural log of a. In other words, bring that in front. So that's all I did over here. Okay, so I'm going to start with this. I'm going to end up with this and show you how I get there. That's a to the u. Well, that's going to be integral e to the u log a du. I'm going to think of this integral right here where my k is natural log of a. So this is my k. That's a constant. So I know from the integral formula this is going to be equal to e to the u natural log of a over natural log of a plus the constant of integration. And then here, it's the same thing. I know that's a to the u. Okay. And we're done. I'm going to do a quick example and close the video. So I'm going to look at 7x squared plus 4 dx times x. And remember, my formula is going to be 7u du is natural log. Sorry, is 7 to the u natural log 7 plus my c. Okay, so but this is a u sub problem. This is my u. U is x squared plus 4. Du is 2x dx. So we write this as x 7 to the u dx. I need to get rid of x dx. I get that from here. This tells me that divide each side by 2, 1/2 du is equal to x dx. So here's my substitution table, and that's what I'm going to use. X dx, 1/2 du, bring the 1/2 out. Okay. And now I just use this formula. Equals 1/2 7 to the u log 7 plus c 1/2 natural log, 1/2 7, plug in u, x squared plus 4 over natural log of 7 plus c. Perfect. Now you look in the book. I'm making this up. This isn't in the book, but the book does things like this all the time. You see the answer is 7 x squared plus 4 over natural log of 49. So how did I get that? Well, let's look at this right here. This is equal to 7 x to the squared plus 4. Sorry. This is equal to 7 x squared plus 4 over 2 natural log of 7. That's equal to 7 x squared plus 4. I'm going to do the backwards version of that and bring that 2 inside. Natural log of 7 squared, which is exactly that. So just beware. Sometimes the book does things like brings this number inside the log. But then if that number is inside the log, then maybe the book will bring it out. So the book likes to be contrary, I think. But anyway, just wanted to point that out.